Um, okay, so Kevin has this, it's almost like a theory that says that when people make compromises to their moral code, they have some ethical um, belief in here's how one should behave. And sometimes people go against that. Like, for example, lying or cheating or stealing. You think you should not do these things, but sometimes the temptation is there. And in fact, we'll talk about this at the, after the midterm, we'll have some more analysis, and I'll show you some results of experiments that sort of test this a little bit. How immoral are people willing to be? Not a lot, but some. But maybe he's saying that there's some prospect theory here, that if you are faced with a situation that is certain, let's say you cause something immoral to happen with certainty, then perhaps psychologically this weighs on you a lot because there's a certainty effect. You know it's going to happen, something bad. You're going to cause something bad for certain. As opposed to the case where it's uncertain. You're probably going to cause something bad to happen, but you don't know for sure. And is there a very significant difference in how you feel about that? And your moral compromise, you find ways mentally to compromise when there's some uncertainty that you just can't justify when it's certain. What do you guys think about that? Do you think that's a reasonable application of prospect theory? What do you think?
Yeah, I would say so, actually, yeah.
Yeah. So, I mean, it certainly goes into the psychology of what people are thinking about. It's deeper than just money. How badly do you want this money or this prospect? Which I kind of think Kahneman and Tversky, when they wrote their paper Prospect Theory, published in 1979, they weren't really thinking about the moral and philosophical questions like this. But why not? I mean, here's my opinion. That's even more complicated. When we look at like what justifies us making a decision, which is we may consider to be unethical, that's a really complicated mechanism in your brain. That's like you search for ways to justify it, don't you? Like oh, I shouldn't think of this example. I don't. It's a terrible example, but it's the first one that came to my mind because I just watched an episode of The Office where they're doing drug testing, and Michael Scott is the manager of the office, and he, for some reason, believes that he will test positive, so he's trying to get somebody else to give him some urine so that he can cheat on the drug test, so he won't get caught. The truth is, he actually didn't take any drugs. It was like clove cigarettes that he doesn't understand the difference. But anyways, there's a moral and ethical question here, whether his subordinate, his name is Dwight Schrute, he's the assistant to the regional manager, whether or not he should sort of give in and allow Michael to cheat on this particular drug test. And they sort of, he doesn't want to do it, but he's searching for ways to justify it. And I don't have a big point here other than we live with this in our lives. When there's something maybe we know we're not supposed to do, if we can justify, if we can think about ways, well, actually it's okay to do this because, everyone does it, or because there's really no victim here. This is a victimless crime, or no one will notice, or you just think of some way where actually it's not unethical. I do believe that really exists. Does that interact with probabilities? I'd imagine it does. When you're thinking of the harm that you cause on someone, if it's certain, that's gotta weigh on you morally more than if it's uncertain. I just think it does. So I can cite some of the literature. What's it called? Oh, I know what it's called. Moral wiggle room. And you can present somebody with a situation where they can use moral wiggle room to justify their actions. If that exists, they're much more likely to do the thing that's selfish. And there have been some experiments on this. Um, Gary Charnas, Martin Duffenberg, I believe, are the two experimental economists who did have papers on this, and maybe some other people that I forget. Um, but anyways, knowing that research, I'm a behavioral economist, so I'm familiar with that line of research. The answer is absolutely yes. People will find ways to justify their actions. And having this sort of probabilistic, I don't really know if I'm going to cause harm. Maybe I won't. Oh, that way I'm fine with it. It is a real thing. It's not what Kahneman and Tversky were talking about in their paper. So for your quiz today, I'm asking you about prospect theory, basically as it was written in 1979, that original paper. And everything that I've talked to you, aside from this little snippet of this lecture, everything else I've been telling you about applied to the original prospect theory. It was about prospects. Excuse me. Prospects are, they're written in a certain format with parentheses where the first number is, whoa, is that just a phone? A loud phone buzz. The first number tells you what your payoff is relative to your reference point. So if it says 100, that means it's like in the domain of gains of 100. If it's negative 100, that means you're in the domain of losses, negative 100. That's the first number. And there's a comma. Then there's another number. That's the probability that you are at that outcome. So if you see 100 comma 0.5 in parentheses, that's a specific thing that Kahneman and Tversky are talking about. That's the case where with probability 0.5, you will be 100 units, $100 of payoff better than your current reference point. Okay, so what I want you to know for this quiz is how their theory applies to those sorts of prospects. And hopefully you know this a little bit. There's a value function which says I value each prospect based on whether it's the domain of gains or the domain of losses according to this thing called the value function. And it has a certain shape to it. The other part of prospect theory is the probability weighting function, which says I don't just weight each possible outcome according to the true probability. I weight each possible outcome according to my personal weighting of this event, which may not be equal to the true probability of the event. And there are certain effects with that too. So if you know those things, those core things, that is what prospect theory that I want you to know about is about. I'm glad that Kevin brought up this other thing. Oh, is he not even here? I'm glad that he brought up the other thing. It's just another way of thinking, how else can this theory be applied? That's always good to think about. How else can this theory be applied? And I sort of agree with his conclusions.
Sorry, I just switched to my phone so I could have the webcam on. My computer's webcam doesn't work.
Yeah. So did you not hear my answer to your, I give a very, very long answer to your question.
I heard it all. It was good.
Oh, good.
But I'm more curious about, I guess, like, if people compromise, like, their moral code or their beliefs, if they're presented with, an asset with large certainty. That was, like, more of where I was, but I guess, like, what your application was, that was more along the lines of, like, what prospect.
Yeah, so prospect theory does not deal with whether you compromise your moral code for a bribe. That's a question that you make in your brain absent. You don't need prospect theory to explain that. That's just about, you can think about what sort of norms or preferences or, like you said, a moral code guides your decision-making behavior. But prospect theory is really about how you make decisions under uncertainty. That's the reason it's interesting. The reason it's an interesting theory is that it shows that there are, let me take a step back. It's not the one that showed for the first time that expected utility theory was false or was violated. It didn't do that. They weren't the first ones to say, hey guys, expected utility theory it doesn't, it's not very accurate in a lot of cases. But what they did was try to form a consistent alternative to expected utility theory that said, actually, in this other theory can explain some of this behavior that expected utility theory just can't explain. So that, I think that's my answer is, I don't think, at least I don't see how prospect theory is a good way to explain why somebody would betray their moral code when faced with a large asset. But if you start talking about the probabilities involved of harming someone, or the probabilities involved of getting the asset, then actually I do think prospect theory has something to say.
That makes sense.
Okay. I have another question here in the chat that says, is it to everyone or just to me? The horse racing example, if I were up 180, and for some reason wanted to bet 20 more, I would prefer to bet on the long shot. At the beginning of the day, I would be more likely to bet on the safer horse. Is this decision the opposite of what prospect theory would predict? I got to read this again because I can't tell. If I were up 180, okay, we didn't really talk about this situation, what happens when you're up 180, but let's just consider it. And for some reason wanted to bet $20 more. Well, first of all, you wouldn't be limited to only betting $20, but let's say that's how much you plan to bet on the next race. I would prefer to bet on the long shot. Let's think about that. Yeah. I think this is actually a bit opposite of what the prediction of prospect theory would be, wouldn't it? I don't know if we've talked about this yet, but maybe let me go to my slides to answer Michael's question. This is about if I've already won some money, how badly do I want to win even more? And prospect theory suggests that, so if your reference point hasn't, I'm trying to answer Michael's question now. If your reference point hasn't changed, it's here, and you're $180 better than that in the gains, how badly are you going to try to get even further into the domain of gains? And the answer is, it predicts not that much. Now you may be willing to bet more with like house money, right? In the sense that, oh, I've won this $180. I'm willing to kind of bet it, at least $20 of it, and not feel bad about losing from 180 to 160 up because I'm still up. But the question is, do I really want to go for the long shot? I can see as a gambler how you would want to, and the truth is, no, prospect theory would not be able to explain that because your value function should be pretty flat at that point in time.
Haven't we discussed some theory that talked about like if you already got the improvement, then you, well, no, it's the opposite. I was going to say the endowment effect would say that because you have the money, you're less likely to part with it through gambling.
So here's,
but I agree with Michael in that if I were up 180 bucks, I go, yeah, I'll bet another 20 bucks on the long shot instead of the sure thing.
Yes, I agree. The rub here is whether or not you think of that 180 as yours, or whether you think of it as house money.
So maybe it's the accounting thing.
Sure, a little bit. I would. So there's an end of the day horse racing betting effect that's documented. That was actually documented before prospect theory. I think in the early 70s, maybe mid 70s. And it doesn't say anything about what happens when people are up, what they do. And partly because I think most of the time people are not up. They don't win money at horse tracks. They usually lose money. But
that's just because they're not using my system.
Yeah, you have a surefire system. But I certainly get this. If you're playing with house money and you don't feel so bad if you end up losing it, why not go for the big payoff? I certainly get that. Psychologically, I think that makes a lot of sense. And I maybe prospect theory doesn't predict that, but you know, it's not getting all of the psychological factors going in there. In other words, I really don't know, because if either way, gaining more money doesn't make you feel that much better unless it's a lot. So I would say there's an issue there of like the scope. Like you're up $180. Maybe you want to go up 1,000. That's your goal. Not to walk home not with $100 earned, but with $1,000 earned, and that would make you feel really great. So I can see that that effect is not being captured, but by this theory. This is not perfect. That's my answer. Is that good? Let's talk about Zachary's question, expected utility function. Sure. You know who talks about the expected utility function? Kahneman and Tversky in their paper. Let's take a little time now I'm going to actually, you were supposed to read the introduction to Kahneman and Tversky's paper, but maybe some of you didn't. Let me, where is it? Sorry, I'm going to find it. I had it open. There it is. And now I want to share it. There it is. Okay, so here's Kahneman and Tversky's paper. Can you see it? I think I'm sharing with you now. It's called Prospect Theory, an analysis of decision under risk. This is the original one, 1979. In econometric, which by the way is the best, if not one of the top 2 economics journals that there is. And they did that on purpose. They wanted all economists to be aware of this work. Okay, and right here is a description of expected utility theory. Right here in the first page. Look down here. Expectation, the utility gained from this outcome x1 with probability p1 ... xn with probability pn. The expected utility gained from that is the probability 1 times the utility of having x1 plus ... plus the probability of outcome n times the utility of outcome n. Utility of what happens when you get xn. So that's a description right there of expected utility theory. Does that answer your question? Who asked? Somebody asked. So why is this in this paper? Because the rest of the paper is a critique of that. What Kahneman and Tversky are saying, I'll remind you again. That's my job as the instructor, is to teach you things. And sometimes I use repetition to really make you understand something. They're going to change these P's. These P's in prospect theory are no longer going to be P's. What will they be? Instead of P's, they'll be W of P. What is W of P? It's the weight of probability P. So don't use the probability P, use the weight of probability P. Well, how can I find W of P? Well, that's why you need this curve called the probability weighting function. It'll tell you. It says, you give me any P, I'll tell you what W of P is. And they look like, well, they're in here too. I guess that would be down. I'm sure there is a description of the probability weighting function, perhaps quite a bit down. Is this it? Nope, that's the value function. There.
I have the graph right here. I can pull it up.
Oh no, I got it. Do you see it on the screen?
Oh yeah.
I'm just giving you one. This is the one from the original paper. And it says a hypothetical weighting function. You know what? It's not very extreme, and it doesn't have, what it has are these jumps. It has these jumps in it, these places of discontinuity. And it says that your decision weight, I said W of P, here they're using capital pi of P. Either way, that's fine. I think in the more modern usages, it's W instead of capital pi. Or is it a lowercase pi? It looks like a capital to me. So that's one change. Instead of P, use the weight of P, which is this function tells you what it is. Like instead of 0.5, I would go up here in 0.5 and see, oh, here it is. At this point on the y-axis, it's more like a 0.3. No, more maybe 0.4. I don't know, approximately. So I replace those p's with these decision weights or weighted probabilities. That's one change. And then the other change is also pretty simple. Instead of having u of x, where are we? I'm going all the way up to the top now. I'm scrolling, which takes a long time. I should have just gone straight to it. Instead of having this u of x1, dot, x1 is some outcome, x2, x3, all the way up to xn. Instead of having u, you have v, which is the value of that outcome. And what's important here, the value isn't just in some absolute sense what the outcome x is. It's the relative position of x compared to your reference point. What's this outcome? Like, let's say you have $100,000 of net worth. Is this a gain or a loss? Well, it depends on what you started with. If you were a billionaire and you lost everything, but now you only have $100,000 left of net worth, that's a huge loss. That would go in the value function as a huge loss. Whereas if you have nothing, if you're broke right now and you find yourself with $100,000, that's a huge net gain. And part of prospect theory is to say all of these situations where maybe you lose a lot of money, maybe you gain a lot of money, it doesn't just matter where you end up, it matters where you started. If you started here and you lost, or started and you gained, psychologically that affects us differently. We already knew that because of loss aversion, because of the endowment effect, because of the reflection effect. I don't know if you guys, did I define for you what the reflection effect is? It means, framing something as a gain versus a loss may change the way I feel about taking risks. I'll go ahead and take I will not take a risk if it's framed as a gain. And I will take a risk if it's framed as a loss. That's kind of what's known as the reflection effect. Okay, so that's it. Did I answer your question about what expected utility theory is? And did I get any other chats? Let me look at my chats real quick. I think what's happening? Maybe I can't see it unless I stop sharing. Nope, there it is. Yes, thank you. Okay, great. What else do we want to do before the quiz? I'm going to keep talking. I like to hear myself talk. I'm going to keep talking about prospect theory before the quiz, and then let's just have the quiz and be the end of the class. Rather than have you guys wait and see, oh, is there going to be more lecturing after the quiz? I'd rather give you the freedom to just end the class period when you're done. So let's start the quiz at, like 10 minutes from now. We should start the quiz. And then
Professor, I actually had just one question, just real quick.
Go ahead.
About the consumer theory, consumer choice theory.
Okay.
Like in general, like I'm just like looking at like the decoy effect and like what is it? Mental accounting and stuff like that. And it seems like it's just about how people really perceive like their money and how they perceive like I guess like with the movie ticket example, like if you lose $10, then like they don't perceive that as much of a loss as if you perceive like an actual movie ticket, then you just don't want to go to the movie.
Yes and no. It's not just that one is seen as a big loss and the other is seen as not a big loss. It's that whether or not you've already spent money on that thing. If I've already spent money on a movie ticket, then I'm less likely to want to spend more money on a movie ticket because of the account. I have a mental account, in my mind account. It's like you're keeping track of how much you've already spent on something. And if you've already spent money in that account, you're less likely to want to spend more. And in general, the theory is we always categorize our consumption, our spending, in such a way to constrain ourselves. And the reason it's behavioral economics and not just standard economics is because standard economics says you should never constrain yourself, because the more options you have, the more choices you have of how to spend your money, the better. That's what standard economics says. Richard Thaler says, wait a second, I know how people actually make their decisions, and it's not in this way where they're every time they have $1 to spend, they're thinking, how can I spend it in the to maximize my expected utility? And remember, I like Richard Thaler. He uses this term econs, and he's talking about the Homo economicus model. You know, when he says, here's how an econ would spend their money, it's not how we actually do it. And that's just one of the ways. Richard Thaler won the Nobel Prize. He has a lot of theories about this sort of stuff, and I just gave you one. And so that's just one anomaly. Also, you shouldn't think that all these anomalies are the same thing. They're not. The decoy effect is different than the mental accounting or what else do I have? I had you watch a video, I think, on arbitrary coherence, didn't I? Thought I did. Oh, somebody's watching the video right now.
Arbitrary coherence is just another name for anchoring, right?
Not quite. Not
What's
quite.
What's the difference?
Oh, good. Anchoring is one example of the arbitrary initial imprinting of your preferences. So the theory of arbitrary coherence is twofold. It says initially preferences are imprinted by whatever experiences or effects psychologically that exist. And one could be anchoring. It's not the only one. What other psychological effect could there be? I don't know, a decoy effect is an effect. You know, you get initially imprinted with, if you watch the decoy effect video, I talk about houses. There's 3 levels of houses, and one of them just looks better because of the decoy effect. Well, the theory of arbitrary coherence says that once your preferences are imprinted with this decoy effect, in the future, you're going to have the coherence is the consistency with which you will adapt to whatever else happens. Let's say the price of that house goes up, you're going to be initially imprinted with the decoy effect. That will be remaining. You know, your brain doesn't say, oh, wait a second, forget about the decoy effect. Now I want to reevaluate these houses. No, once you've been imprinted with the decoy effect, you'll always have it. And that's why I just wanted to correct you. I think you were definitely on the right track, Peter, because usually in my examples, I give anchoring, and that's partially my fault.
That's a clear example of it.
Yes, but I don't want you to think that it only applies to anchoring, because I think that's a misreading of the theory.
So the printing idea, that's basically what arbitrary coherence is. Is that what that is?
There's 2 phases. The first phase is imprinting. Do you know what imprinting means?
That's like when you have like an anchor has been presented. And
for example, an anchor is an example of a way to have, it's like your first decision in your mind, what should my preferences be over this? You've never thought of it before. So somehow they get imprinted in your brain. Okay, but then once you have these preferences and they're imprinted, now you behave coherently in the future, which is what standard economics says you do, which is like when the price goes down, you demand more. Quantity demanded goes up. When the price goes up, quantity demanded goes down. That's an example of a coherent economic theory. So arbitrary coherence is that initially your preferences are imprinted, and it could be in some arbitrary way. There could be anchoring, there could be a decoy effect. What else could happen? I don't know. Any number of phenomena could happen while your preferences are being imprinted. But once they're imprinted, afterwards you behave consistently. That's the theory. That's it.
Use that to argue like possibly why standard economic theory is in place, like why a lot of people.
Why we need to keep it. Yeah, let's not throw it away, because actually it works in most cases. You know, the way that it's violated, at least in terms of consumer theory, we're talking about these anomalies and how people make choices as a consumer. Most of those anomalies happen right at the beginning, right when their preferences are being imprinted. That's where these anomalies really occur. It's not that they're bad. You know, you've been investing in your 401k for years and years, and all of a sudden you start to do something stupid and arbitrary. That doesn't happen. You've already decided at some point in the past how important retirement, your investment for your retirement is versus how much you want to spend now. and you're sort of consistent. If somebody offers you a benefit that says, hey, if you invest more in your 401k, I'll subsidize you, you're going to react to that in a consistent way and say, okay, well, before I was saving $2,000 a year to my retirement. Now that I have this extra benefit, I'm going to save $3,000 a year for my retirement. So this is actually a very broad theory. This is just a theory that says psychological phenomena basically exist in the initial phase of imprinting your preferences, and at least in terms of consumer choice, you do still behave coherently after that. Make sense?
Yes, it does. Thank you.
Cool. In the PSTVT context, on concave and the loss, what is PSTVT? In the PSTVT context, I'm reading a chat now. Michael, I don't understand. Oh, the value function for prospect theory? Okay. Sorry. Is the convex or concave in the loss domain? So yeah, there's an answer to this. It is convex in the loss domain and concave. Did I say it wrong at some point? If we were given this question, should we answer concave or convex? If I ask you if the value function, how does it look in the loss domain, you should say convex. If I say, how does it look in the domain of gains, you should say concave. I hope I didn't make a mistake. They look the same to me. Okay, no, they're not the same. Okay, let me try to explain that. I have maybe 5 more minutes before I want you to start the quiz, but let me get a picture of, actually their picture of the value function isn't great. You can hardly tell that it's curved. And you know what? I think I know why Kahn and Tversky didn't make a really extreme value function. They didn't want to scare people. They didn't want economists to look at them and say, that's ridiculous. Nobody has a value function like that, like really extreme. If you look at my slides, they're actually pretty extreme. Where's my slides? I'm going to show you my slides now. Here we go. Meeting control, stop share. I'm going to share my slides on prospect theory. Look at how extreme that is. Now, if you just said that doesn't look any different, maybe what you mean is it kind of looks like the continuation of just one curve. Maybe that's what you're saying, like the domain of losses and the domain of gains, it kind of looks like a continuous S curve shape. And I'll agree with that. But what does it mean to be concave or convex? That's about how the slope is changing. Is the slope increasing? If the slope is increasing, that's what we mean when we say convex. If the slope is decreasing, that's what we mean when we say concave. And I'm pretty sure every one of us can look at this graph and say, over here on the left, the slope is increasing. You see that? It's getting higher. This is, like the slope. Imagine a line that was showing you the slope. It's getting higher and higher and higher. The slope is increasing up until this point. At this point, now the slope is decreasing. Slope is decreasing. It's getting flatter and flatter. That's what it means to be concave. You should think of concave as being the slope is decreasing, and you should think of convex as the slope is increasing. And clearly, even though maybe what Michael is saying is it looks like one consistent graph, one consistent value function, that's fine. But it is still the case that to the left is convex and to the right is concave. And that's the point. Oh, I see. Starting from infinity rather than the origin. Yes, good point. Oh, okay. So you thought starting from the origin going to the left, then it's getting flatter and flatter. That's true. Starting from the origin, going to the right, is it getting flatter and flatter? That's true. That's true. And in fact, psychologically, that's part of the justification for this value function, is that we get less and less sensitive to the extremes. It's true for how bright a room is or how loud a noise is. You know, if it's really loud and then it's a little bit louder, we don't perceive that difference. But if it's, you know, soft and then a little bit louder, we can really perceive that difference. Okay, good point. I'm glad I cleared that up. Yeah. This was worth talking about, I think, to clear that up. I don't think I really have anything else I want to lecture about today. I say we just do our quiz. I'll give you until 1:45 to do the quiz. That should be more than enough time. And I'll stick around too, in case you guys have questions. Right. I'll tell you what I didn't get to today that we'll have to do next time is other implications of the value function, and this stuff about editing prospect theory. It's not on the quiz. It's something we'll talk about after the quiz, which is what happens before people evaluate according to the value function, and they do some editing down. They sort of, what makes sense? What's really going on here? And we'll talk a little bit about that. And then, I don't know if I want to go into this. The formal description of prospect theory has these functions and stuff. May or may not talk about that. But this I definitely will want to talk about next week. Next week we'll talk about what's called prospect theory in the wild. And Colin Kammerer is also one of my favorite behavioral economists. And he wrote this paper about 10 cases that show in the real world how prospect theory explains what people are doing. Much better than the standard economic theories. Okay. I'm going to stop share. I'll probably also stop recording because we're going to go to